Okay. Introduction. Pretend that this function right here, okay, it doesn't, but pretend that this function looks like this picture, like this graph here. It doesn't, we just pretend it does. Remember back to our discussion last Thursday that talked about how if I want to find the slope right here at A, what I'm actually going to do is create a secant to the left and a secant to the right, like that. I'm going to find the slope of both secant lines. I will then make the two secant lines infinitesimal in length. So the picture would change to something like this. Once those lines are infinitesimal in length, I can deduce that the slope right here at A, hey, that slope here, that slope is a little bit more than 10. This slope, turn these off, this slope here, a little bit less than 10. Therefore, I conclude the slope precisely at A must be 10. So I find the slope at A by finding two secant slopes. It's important that you not forget that. Questions? Okay. However, finding the slope at A using that method is actually difficult. So we have this set of shortcuts to make the whole process a lot easier. So we will actually never find in this class, at least not a lot, maybe once in a while, we typically will not find the slope right here at A by finding secant slopes. At least it won't seem like we're doing that. We'll be using the shortcuts. The shortcuts actually do find secant slopes. You just can't tell that they do that. It's kind of hidden. If you want to see how these actually work, you have to go online and spend some time learning on your own. I don't cover it because the AP test doesn't really test it heavily. So anyway, it's going to feel like we're just doing algebra, but in reality we are finding two secant slopes, we're making them infinitesimally short, and then we're finding the slope at a point. So we're seeking this. We want to find the change in y divided by the change in x, because that's what slope is. To find this, we literally have to say, well, what's y? Well, y is this. So we want to find the change in that thing divided by the change in x. So that's what we write down. We're starting with this, so it's on your paper you should always write down the problem first. So we write down this. Next line, you indicate, I want to find dy dx. So just write that down, dy dx. That's what you're trying to find. But it's all about using the equals sign. The green line above says y is the same thing as cosine of e to the negative 3x to the 4th. So right here where I've written dy, that's no different than writing d of cosine of e to the negative 3x to the 4th. Because y and this cosine expression, they're the same thing. So if you're not comfortable that the orange line is a accurate statement, meaning it's true, talk to me and I'll help you see it. But that's where you start. Questions? Sometimes I'll say it differently. I'll say what we're doing is we are going to apply the derivative operator. So this is what I call the derivative operator. We'll say we're going to apply this derivative operator to both sides of the equation. That's another way that you'll hear people talk about it. But honestly, the way that makes the most sense is the idea that our goal is to find this, dy dx, but y is simply this So I just write d of that same y over dx. I'm just taking advantage of what equal means. Questions? Okay. If you had a calculator computer, you're done. Because right here, this is a formula for finding the slope at any point of this. That's what we're trying to find, a formula for finding the slope, right here, slope at any point of this thing. And this formula would do that if you have a calculator or a computer. Without a calculator computer, which 2/3 of the test, AP test requires you to do it without a calculator computer, we've got to have a formula that's a little easier to use. That's the purpose of the rules, to transform this formula into something that is more user-friendly when we don't have a computer. Questions about anything? Curiosities, anything coming to mind that you feel like you want to talk about? Okay, so what I do now is I have to go find a rule on that pink sheet that matches that. So the rule I find is right here. Let's see, page. Just a second. The cosine rule, that's what I need. So there's the cosine rule. Copy that. Go back to here. 16. Paste that rule in. So that's the rule I need. Here's how I know that that's the rule I need. I am looking only at the left side of the rule. I'm only looking here, the left side. And I'm looking to see if that left side matches exactly with what I have here. And it does, as long as I have g of x equal to e to the negative 3x to the 4th. As long as I pick g of x correctly, I have a perfect match. You need me to talk more about how I found the correct rule. The main idea of this process is find a rule, use it, find another rule, use it, find another rule, use it. Cool. So I'm going to apply the rule now. The rule says that what I have right here can be rewritten like this. Here's a very interesting thing about how these rules work. The rule is first applied, always, to all of the formula that we're trying to find the derivative of. So the rule is first applied to all of this. That's why you see over here d over dx of all of this. So the rule is being applied to all of it. Once we use the cosine rule produces part of the final answer. So this portion of the rule is going to tell us a piece of the final answer for our like we're trying to find dy dx. That's what we want to find way down here, the formula for dy dx. The cosine rule has already given us part of that final formula right there. But the cosine rule also produces another problem that needs to be handled. And that's how the rules always work. I like to use the example of the movie Inception. We start here, and then we work our way inward. So we applied the derivative operator to all of that purple. We use the cosine rule. Now the cosine rule is only going to apply the derivative operator to a smaller portion of what we started with. So let's use the rule. Let's see how that happens, how that works. Pull that down. Okay, dy dx, you need to get used to different styles. So another way you'll see this written is d over dx of y. Like that. It doesn't matter how you write it, you just have to be aware that there are different ways. Now I just use the rule. Equal means the same as. So this is the same as negative sine. So -1 times sine, parenthesis, my g of x is this. There's g of x. Oops, 3x to the fourth, sorry. Now I have d over dx of that same g of x. Any questions from anyone? Please, Dave.
How do you tell the difference between the part of the equation that needs to be worked and the part of the equation that you just found from using the rule?
Awesome. 4 points. I'm giving 4 now because I only see you every other day, so I had to up the stakes. You pay attention to the derivative operator. So on the line here, the derivative operator, d over dx, is applied to the entire right half of the equation. Therefore, I've got to go find a rule that looks like this. And I did. Once I apply that rule, this part of my expression is done. Like that blue section here, that blue section is going to carry all the way down to here. We won't do anything with it other than just keep writing it. It's complete. But I still have a ddx operator. And now the ddx is only operating on this much. So it's that idea of inception. I first apply ddx to all that you see in purple. Now I'm only applying ddx to this piece. The ddx operator works its way inward, like that. I don't know if that answered your question. 4 points. Anybody else? Okay, cool. Now we need to find a different rule, because this rule does not fit this instance of the ddx operator. So I look at the pink sheet, I find something else. Let's clean this up. Pull this over here. So now I need something else, and I'm looking for the E rule. It's right here. There you go. So Dave gets 2 more. That's why you should always raise your hand, because then I remember your name and I keep saying it over and over again. We have a match again. We have ddx. So we have ddx here of this. That looks just like this. D over dx of this. All I've got to do is correctly identify g. Every time I use a rule, g changes. Like that. So g isn't something that's permanent, it's just something we identify as we use the rule. Questions? So now you just use the rule. Pull this out of the way. Another way to write this, another way to write this piece right here, this one, is to just write y prime. This just gets copied. Don't do this. That's your little secret symbol for I don't want to retake the test. That's not allowed. Don't do that. -1 sine e to the -3x to the 4th. Now I use the E rule, so I'm taking advantage of the equal sign. So I have to do E. Here we go, E raised to the g of x. Here's g of x. Then I have d over dx of g again. So d over dx of g. Made a mistake. Sorry, don't write that down. No e. Just 3x to the 4th, negative. Like so. Anyone bothered by anything? Cool. So once again, the idea of inception showed up. Now my ddx operator is only operating on negative 3x to the 4th. I'm burrowing inward, getting deeper and deeper into the original equation. So the process now is starting to feel a little bit tiresome because we just keep doing the same thing over and over again. So now we need another rule. Because we've got, as Dave said, 2 more for Dave. We've got the ddx operator here. We've got to find a rule that looks like this in green. So that particular rule on your sheet is known as the multiplying constant rule. So right here, copy that over. There's a typo on the, I think it would be easier to understand if my multiplying constant rule, instead of using f, it used g. So we kind of have that idea of, someone change that. I want this to say g of x. It technically does not matter, but I think it makes it easier to talk about what we're doing. Because we keep choosing a different g every time we pick up a new rule. So now what we have is, we have this constant, negative 3, and g of x is x to the 4th. So as I said, every time we use a rule, g changes. And we've got this constant a, which is negative 3. So that's where we're at now. Questions? Please.
So you have to do the negative 3 x first. You can't just use the power rule before the multiplying constant.
4 points for Matthew. The reason you can't use the power rule, and it's actually a very common mistake. I was helping someone this morning with this. It's exactly the mistake that was made. We say negative 3x to the 4th in such a casual and quick way that we tend to trick our brains into thinking that what we have here is negative 3 multiplied by x, and all of it is being raised to the 4th power. But it isn't. It's really negative 3 multiplied by an x that is being raised to the 4th. So they are separate. The power rule only allows me to work on that. It doesn't allow this. So that's why I used the multiplying constant first. Does that make sense? 4 points. Now there is a shortcut that I do not have in the pink sheet that I will show you in a day or two that makes this kind of go a little bit faster. But I like to start with the multiplying constant rule because I found if I don't, people forget that it's necessary in other situations. So. Okay, so the rule that Matthew talked about, there's 2 more for him, is the power rule is what we need now. Well, actually, the multiplying constant first, then we will use the power rule. So as long as I'm here, let's copy that over. So that's right here. Back. So using the multiplying constant rule, all I'm going to do is pull out the negative 3. So the next line goes pretty fast. Here's a new symbol you should also be familiar with. Y prime of x. And let's don't use fluorescent green, that's a little rough. So all we do is take out the negative 3. Make sure you're using parentheses so you don't lose track of the fact that you're multiplying. So we have d of negative 3x to the 4th. Again, you must have notation that looks just like mine if you want to retake test 2, so make sure you're writing as I write. Question? Please.
So is that the order it follows every time? So it's y, and as you go down the inception, y to d of y over d of x, to d over d of x, y, and to y prime, the y prime of x.
Oh.
Or is this all just different ways to write?
4 points for Charlie. Really good question. These are just 4 different ways of writing the exact same thing. So there's no need for you to do that. That was just me introducing 4 different things that mean the same. Does that make sense?
Yeah.
Yeah, you can literally choose whichever one you like. And they're fine, as am I. So, does that answer your question? Yes. Perfect. How many noticed my mistake here that I fixed as I was helping Charlie? Give yourself 4 for that, my bad. Sorry. Other questions? Okay, now we're ready to use the power rule. So again, that inception thing showed up. We just keep getting deeper and deeper. So let's get rid of this. And grab the power rule. I think it's right here on the clipboard. Paste. There we go. Okay, notice how g of x changed once again. This time when I'm using the power rule, g of x is going to be just x. And the n in the power rule will be 4. We need to talk more about that. Cool. So using the rule, it says I'm supposed to write down n first, and g of x raised to the n minus 1, then d dx of g of x. So we're going to do all of that. So this becomes, we'll go back to dy dx, it doesn't really matter. Negative 1 sine e to the negative 3x to the 4th. E to the negative 3x to the 4th, multiplied by negative 3. Okay, now we're ready to use the power rule. So we're supposed to write down n, which is 4. I highly recommend you use some extra parentheses. It's really common to get mixed up between multiplication and subtraction. So just throw in an extra set of parentheses. The g here is x. The n minus 1 is 4 subtract 1. And we'll have d of x over dx. Like that. Questions? Cool. This is your indicator that you are really done using the derivative operator, because dx divided by dx is 1. Multiplying by 1, we're done. We have had the dx, the derivative operator's worked its way all the way to here. Okay? And that's how this process always works. So the nice thing about Unit 2, once you get the hang of the process, there's not anything new to learn. You just get better and better at algebraically doing the process. And we also want to get better at not writing so many steps. I have you write a lot at the beginning because it really helps you memorize, really make sure you're understanding properly. But to be fair, I expect that in just a few days, all of you would have been able to look at the original problem and say this. dy dx equals, I'm just looking here, not anywhere else. Let's see, it's going to be negative 1 sine of e to the, I don't have enough space right now. I'll have to show you in a second. We'll show in a minute. So anyway, last thing, just clean it up. Keep track of the fact that you have factors. Here's one factor. Here's another. Here's another. Another. So 1, 2, 3, 4, 6 factors. So as Amanda Lindstrom immortalized, factor is a thing times a thing times a thing. You can multiply factors in any order you choose. So I'm going to choose to take -1 multiplied by -3, which is +3, times 4 would be +12. So dy dx is 12. Next, I think I'll use the x to the third. After that, I think I'll use the e. There's no rule that says what order these should be in, but just my choice. Questions? Look up here. Pick the right answer. Done. So, did I mess up? Shoot. Pick the right answer. How many saw here? 2 points. Cool. Questions? Awesome. That's what we're doing for the assignment that was supposed to have been done today, as well as the assignment that is being handed to you today, which is the pink assignment, as well as the assignment that will be handed out in class on Friday, which you now have in your hands, which is the yellow. So we'll stop this video.